Today, we're announcing an AI that can autonomously generate scientific projects, run experiments, and publish its findings. This marks a huge leap towards fully automated scientific discovery. Let's get into it. Let's start with today's featured paper, FARS, a fully automated research system deployed at scale, by Qiong Tang and Yunfan Xiao from Analemma. FARS represents a significant step towards the grand challenge of automated scientific discovery, claiming a fully autonomous system that can ideate, experiment, and report findings at scale. Here's a full breakdown.
Here's an overview of our fully automated research system, or FARS, which is designed to run many research projects in parallel. It takes project from start to finish, producing outputs like the arXiv preprints and GitHub repositories shown here, all attributed to FARS. Feeding into this system are specialized agents for each stage of the research process. This begins with the initial ideation phase, which then leads into planning, experiment, and finally writing. Next, to coordinate these agents, the system provides access to a central set of resources. This allows them to use tools and skills to interact with a shared file system, a GPU cluster, and various model inference endpoints. This entire pipeline enables autonomous project advancement, taking an idea all the way through the research cycle. The system can generate multiple projects, each resulting in a final manuscript and code, as represented by the flow from writing to the final outputs. FARS, when evaluated by a self-automated reviewer, SAR, achieves a mean rating of 5.00, substantially outperforming all other SAR-reviewed systems. It also has 1.8% of papers rated 6 or above, a metric where human reviewers of FARS achieve a much higher 11.4%.
Up next, our second paper out of 10, Scaling Storm-Resolving Atmospheric AI Simulation to the Entire Planet by Ziyuan Hu and Noah Brenowitz from NVIDIA. This work represents a landmark achievement in AI for science, demonstrating the first AI model capable of running stable, storm-resolving climate simulations at a global scale, a grand challenge in the field. Let's break down its key contributions.
First, our model operates using a tile-based approach, where a sample tile from the globe is processed individually. The core of this is the tile update model, which auto-regressively predicts the next state of the atmosphere for that tile. Feeding into this model, the current atmospheric state is first broken down into small 3D chunks using a patch embedding. These patches are then processed by the local transformer, which uses neighborhood and column attention to focus on relevant interactions. Next, to handle the Earth's spherical geometry, we introduce a novel position encoding called Stereotype, which is a key part of the local transformer. This allows the model to understand location and orientation consistently across the globe, as illustrated in panels D and E. Finally, the output from the transformer passes through a full-resolution de-aliasing decoder. This step is crucial for upscaling the result and generating a clean, high-fidelity prediction of the future atmospheric state, xt plus 10 minute. The Strata method substantially outperforms the persistence baseline across all metrics shown, including precipitation skill and RMSE for temperature and zonal wind. When coarsened to 1 degree, Strata also generally shows lower RMSE than the ACE2 on screen method for temperature and zonal wind.
Up next, our third paper out of 10, Moral Safety in LLMs, Exposing Performative Compliance with Puzzled Cues by Mohammed Amin Shafi and Yulia Tsvetkov from University of Milan. It introduces the crucial concept of performative compliance, demonstrating that models feign fairness when explicitly prompted but retain biases in more realistic scenarios, thereby revealing a major flaw in current safety evaluations. Let's break down its key contributions.
In the direct panel, we see a baseline where the model is given an explicit demographic cue on a sign. We then systematically vary this presentation, as shown in the puzzled panel, by hiding the same identity within a complex logic puzzle. Feeding into that, notice the robot's reaction in the puzzled panel when its compliance is tested. It now rejects the request with a red cross, showing that its initial safe response was merely performative and failed as soon as the cue was less obvious. Finally, this brings us to the genuine safety panel, which shows the ideal outcome our metric is designed to find. Here, the model's decision is invariant, giving a green checkmark whether the cue is direct or puzzled, demonstrating true moral robustness. The puzzled, hard method generally shows a lower average net decision bias compared to the direct method across various demographic groups. while the direct method consistently exhibits a positive bias, puzzled hard, often shifts the bias closer to zero or introduces a negative bias.
Up next, our fourth paper out of 10, The Consistency Dilemma in LLMs, Generator-Evaluator Agreement and Vulnerability to Mistakes by Marina Mankortis and Zoe Hitzig from Massachusetts Institute of Technology. By identifying and systematically measuring the critical flaw of Generator-Evaluator inconsistency, this paper delivers a surprising and field-redirecting finding that undermines the core assumption of many agentic AI architectures. Let's break down its key contributions.
Our approach is built on this shared test structure, which outlines a four-step process from concept identification to a final result. The outcome is a binary signal measuring the consistency between what the model generates and what it evaluates, which is the core of our method. Feeding into this, we test models using a variety of challenges, as shown in these three inconsistency examples. This allows us to probe a wide range of concepts, from benchmark-adjacent problems to ontological properties. Next, to ground our work in a real-world context, we applied this same framework to a high-stakes clinical domain. We specifically analyzed cases where the model's outputs were validated as mistakes by physicians to understand the practical implications. This analysis revealed a key finding, which is illustrated well in the rationale example. The model is marked as inconsistent because, as the reason states, it endorsed reasoning that it itself generated as incorrect, highlighting a fundamental dilemma. The evaluated LLMs demonstrate strong performance on several ontology tasks, such as identifying valid examples and listing wrong attributes, with average scores across all models reaching up to 0.91. However, these models show significant challenges in rationalization tasks, particularly correct for incomplete reason, where their average performance is notably low at -0.08.
Up next, our fifth paper out of 10, Free-form association tasks reveal stereotype hallucination in large language models by Xinrui Chloe Zhao and Amir Goldberg from Stanford University. By using more cognitively realistic free association tasks, this research provides compelling evidence that LLMs don't just repeat human stereotypes but actively hallucinate and structure them in ways that differ from human cognition. Let's break down its key contributions.
To start, we have our survey pipeline, where human participants undergo a random selection process. They are shown a series of random stimuli, and we collect their initial, unprompted thoughts. This process then splits into two paths for our dual-order elicitation. We collect their direct first-order associations and also their second-order predictions about how different groups would respond to the same stimuli. Next, we mirror this entire process in the LLM pipeline. The model is also tasked with generating both first-order and second-order associations based on the same set of stimuli. This comparison reveals what we call stereotype hallucination in the models. The LLM's predicted associations for each group pair, like rep and dem, are often stark and stereotypical in ways that don't match the human data. GPT and llama models consistently demonstrate higher percentages across all measured categories, such as political, gender, and personality, when compared to human responses, especially in the second-order condition. Among the models, GPT frequently records the highest scores, reaching 99.9 for personality and 97.0 for routine in the second order.
Up next, our sixth paper out of 10, GenPage, Towards End-to-End Generative Homepage Construction at Netflix by Lechuan Wang and Linas Baltrinas from Netflix. Backed by a major industry player, this paper demonstrates a radical and successful simplification of a core industrial system, replacing a complex multi-stage pipeline with a single, powerful generative model. Let's break down its key contributions.
Here's a look at the training lifecycle for our end-to-end generative model, which unfolds over time. This entire process, from the initial large-scale training to the daily updates, represents the complete system that generates homepages. Feeding into the model's generation process, we use context like the user and request, which is represented here by the use of today's data as input. The system then auto-regressively generates the full page structure based on that prompt. Next, we adapt a training recipe from large language models, starting with this pre-training phase. This step uses a large historical window of data to give the model a foundational understanding of how to construct a page. Following that, the model undergoes post-training, which is a crucial step for refinement. This is where we fine-tune the model using methods like reinforcement learning to optimize for specific member-facing metrics. Finally, to ensure the model performs well at industry scale, we incorporate several techniques, most notably these daily incremental updates. This keeps the model fresh by continuously training it on the most recent data available. The method utilizing pre-training is compared against a baseline without pre-training. It consistently outperforms the baseline, achieving a lower loss and higher row AUC and entity AUC scores.
Up next, our 7th paper out of 10, World Narrative Model for Highly Controllable Video Generation, a paradigm shift from pixel sampling to physical world orchestration by Yi Chun and Su from Shanghai Jiao Tong University. This paper proposes a fundamental shift in video generation from pixel-level sampling to explicit 4D world control, addressing the single greatest obstacle to professional use. Let's break down its key contributions.
Our approach introduces the World Narrative Model, a new paradigm for video generation. It takes various multimodal inputs and processes them through a structured pipeline, starting with static world generation and then dynamic spatiotemporal generation. Feeding into this model is a collaborative agent system that translates diverse multimodal inputs like text, images, or even video. These are intelligently processed to inform each stage of the world-building process. The output is a comprehensive and editable 4D world, captured as an instance-level 3D plus T parametric representation. This breaks the scene down into a world model parameter set, with explicit controls for geometry, assets, characters, and more. This detailed parameter set then serves as a deterministic blueprint for rendering. It drives a video model, which acts as a neural shader to faithfully translate the structured world into the final rendered video frames shown here. Finally, the system is designed for human interaction through a platform with director consoles. This allows for precise refinement of dynamic elements, such as planning the camera trajectory and parameters to frame the perfect shot. Compared to prior methods like CDance 2.0, Klingo 3, and TapNow, WM Hours offers a substantially broader and more granular set of control modalities for video generation. It uniquely provides instance-level object editing, decoupled editing, and deterministic output, alongside parametric control for elements like camera, lighting, scene layout, pose, and character staging.
Up next, our 8th paper out of 10, CoLT, Teaching Multimodal Models to Think with Chain of Latent Thoughts by Lianyu Hu and Yang Liu from Nanyang Technological University, Singapore. This work introduces a brilliant and intuitive new paradigm for AI reasoning that could resolve the fundamental tension between performance and inference cost in chain-of-thought prompting. Let's break down its key contributions.
First, let's look at the core of our method in panel 4, the chain of latent thoughts, or CoLT. Instead of generating explicit text for each reasoning step, our model generates a compact chain of these latent hidden states to represent its thinking process. To make sure these latent thoughts are meaningful, we introduce a lightweight external decoder for supervision. This decoder's job is to translate the abstract latent thoughts back into understandable text, providing a clear training signal. Next, this supervision is applied in two complementary ways, which we call dual-mode supervision. The forward mode aligns latent thoughts with previous steps, while the backward mode decodes them into the next textual step, ensuring they are both grounded and predictive. To further improve the reasoning quality, we also add internal step-level supervision. This encourages each latent thought to be predictable from the previous one, creating a smooth and logical chain from one step to the next. Finally, a key advantage is efficiency during inference. All of this supervision scaffolding, including the external decoder and internal prediction loss, is completely removed, allowing the model to reason quickly with just the core latent chain. CoLT achieves an average score of 79.1, outperforming all other open-source models in the 7-8B scale, including Qwen 3, VL, and various latent reasoning methods. It demonstrates particularly strong performance on chart QA and text VQA, with relative improvements of plus 9.6 and plus 6.1 respectively.
Up next, our 9th paper out of 10, One Video, One World, Turning Monocular Video into Physical 4D Scenes by Juanhao Chun and Yufei Wang from Shenzhen International Graduate School, Tsinghua University. OVAL provides a breakthrough capability for embodied AI by creating physically realistic, simulation-ready 4D worlds from single videos, solving a major data bottleneck for the field. Let's break down its key contributions.
First, we take the input video and feed it into our VLM-guided scene decomposition module. This automatically performs object labeling and segmentation, and then classifies each object as static, rigid, or deformable. Feeding into our next stage, this classification directs the system to perform category-aware reconstruction. For deformable objects like the dinosaur, we use a video to 4D model called Motion 324 to create a mesh sequence, while static and rigid objects are reconstructed using an image to 3D model like High 3D Gen. Next, to place these objects correctly in the world, we use an iterative scale and orientation recovery process. This loop uses foundation pose to update the object's orientation and a multi-view rendering approach with Roma v2 to estimate its true metric scale. Finally, all the elements are brought together with realistic physics during per-frame pose tracking. The scene geometry estimation provides a ground plane, ensuring that objects are placed correctly on surfaces for a physically plausible final scene. OVAL substantially outperforms all prior methods across most key metrics, including scene IOU, object IOU, PL, in-clip, and especially processing time per frame. For example, OVAL achieves a processing time of 3.35 seconds per frame, which is significantly faster than any other method, though it does require more VRAM than some baselines like CAST.
Up next, our 10th paper out of 10, Embodied CAD, Solver-Grounded LLM Agents for Parametric BREP Assembly Modeling by Fumin Liu and Lin Yang from Nanjing University. This paper presents a highly credible and practical agentic system that solves a real-world industrial problem by grounding language model outputs in a geometric solver, representing a blueprint for reliable tool use. Let's break down its key contributions.
Our system begins with a user's intent, which is fed into the LLM planner. This planner acts as the core agent, making state-aware choices about what to do next. To make these choices, the agent draws from the stratified skill library shown at the top. This library organizes operations into levels, from low-level primitives to high-level macros. Next, the planner's chosen skill is passed through the resolver and then to the skill executor. The executor translates this into concrete skill calls that are processed by the CAD solver to modify the model. Finally, the CAD solver provides detailed execution feedback about the result of the operation. This feedback is formulated into a training signal, which is used to improve the LLM planner's performance over time. The embodied CAD best method substantially outperforms the RDCAD style and ToolCAD style proxy methods. It achieves perfect scores across visual, exec, and coverage, whereas the proxy method scores 0.000 for exec, and significantly lower for coverage.
Those were today's top papers. Now, let's zoom out. ArXiv received 739 new computer science papers across 53 subfields today. Here are the trending areas shaping the field. Zooming out, today's research shows AI pushing into the physical world, from generative 3D content to advanced robotics. We also see a strong focus on formal verification. Let's take a quick look at each.
Trend 1 of 10, AI Trust and Oversight. Ensuring AI systems are reliable, transparent, and accountable through monitoring, governance, and quality assurance to build trust. This cluster covers 104 papers. Representative work includes Thinking Out Loud, Real-Time Deception Monitoring in Asymmetric LLM Negotiations, AI Transparency, Governance Compliance or Stakeholder Requirements, and the Consistency Dilemma in LLMs, Generator-Evaluator Agreement and Vulnerability to Mistakes. Trend 2 of 10, Advanced Learning Algorithms. This trend explores novel, efficient, and biologically inspired algorithms for learning, optimization, and complex system analysis. This cluster covers 86 papers. Representative work includes Local Pheromone Network, Sparse Local Learning with Multi-Scale Synaptic Trails, Consolidation, and Replay, Criticality-Constrained Iterative Pruning for energy-efficient spiking neural networks via Combined Importance Scoring, and what drives interactive improvement from feedback. Trend 3 of 10, AI for Health and Audio. Leveraging artificial intelligence and audio processing techniques for diverse healthcare applications and advancements. This cluster covers 124 papers. Representative work includes ASR-agnostic multimodal spectrotemporal modeling for early dementia detection. Can physician expertise improve machine learning identification of delirium? And explainable artificial intelligence for the detection and characterization of stage B heart failure. Trend 4 of 10, Formal Verification and Logic. This trend explores rigorous logical and formal methods for verifying system properties, reasoning about data, and analyzing computational structures. This cluster covers 41 papers. Representative work includes a lean for formalization of Scott's continuous lattices, 1972, algorithms and complexity for geodetic sets on interval and chordal graphs, and automated reasoning with nested data types. Trend 5 of 10, robotic vision and physical reasoning. Robots leverage vision and language to reason about physical interactions, enabling complex manipulation, navigation, and understanding of the real world. This cluster covers 69 papers. Representative work includes position. Vision language action models cannot be verified to perform physical reasoning, VTL, temporal logic-guided zero-shot natural language navigation via vision language models, and vision language procedural reasoning for context-aware reward modeling of robotic endovascular guide wire navigation. Trend 6 of 10, physics-based modeling and simulation. Developing and applying computational models based on physical laws to simulate complex systems and phenomena. This cluster covers 51 papers. Representative work includes unveiling the multi-physics complexity, an isogeometric framework for inducing bifurcation and tracing post-buckling paths in electroelastic thin shells, stochastic analysis of fade duration using Wiener chaos expansion and Malayavan calculus, optimal importance sampling via adaptive SGED, and joint discovery of governing partial differential equations from multi-source datasets by competitive optimization. Trend 7 of 10, autonomous transportation and planning. This trend explores advanced planning, control, and coordination strategies for diverse autonomous vehicles, enhancing efficiency, safety, and robustness in transportation systems. This cluster covers 32 papers. Representative work includes locker-based truck drone routing with integrated considerations of pickups, deliveries, and no-fly zones, DCIP, a dynamic coordination planner for signal-free intersections using diffusion model-based multi-agent motion planning, and wind and state estimation on SE. 3. Comparative evaluation of EKF and UKF with continuous and discrete quadrotor models. Trend 8 of 10, generative 3D content creation. AI-powered methods for generating diverse and realistic 3D content, encompassing geometry, textures, and dynamic scene elements. This cluster covers 117 papers. Representative work includes cross-modal hierarchical fusion for multi-sensor ground observation, polyflow, continuous topology embedding flow matching for artist-style mesh generation, and Dante W, diffuse albedo neural texturing in the wild. Trend 9 of 10, AI capacity and societal impact. Understanding and managing AI capabilities, infrastructure, and their profound societal and ethical impacts across various domains. This cluster covers 71 papers. Representative work includes qualified educational capacity planning under heterogeneous student support needs, a synthetic benchmark and decision support framework, mapping the artificial intelligence divide in Africa, infrastructure, accessibility, and capacity, and FAIR+S, a validation study of a framework for sustainable research data and software. Trend 10 of 10, Edge AI and network optimization. Leveraging AI at the network edge to optimize performance, security, and resource allocation across diverse distributed systems. This cluster covers 44 papers. Representative work includes an AI-based solution for secure service provisioning in IoT, CoLT, constraint-aware learning optimization for joint resource allocation in double-active RIS-assisted wireless networks, and TinyML for on-device and edge analytics in wireless networks. A survey of deployments, opportunities, and concept drift mitigation.
That's all for today's ArXiv Computer Science Daily. If you found this helpful, please leave a comment, and subscribe for daily paper summaries. See you tomorrow. Thank you to ArXiv for use of its open access interoperability.